I'm Paul. I get blamed for everything that goes on in the project because we make vibrators. I joke about it, but it's pretty much true. We got the opportunity to work with Dr. Lay and Dr. Taylor, our company, in trying to recognize just exactly what some of the issues are, or why our product doesn't play nicely with all mixed designs or processes in vibration of pavements. And they've helped me out tremendously, both of them in the lab. Big believer in the box test, big believer in the V. Kelly test. It's nice to have development of real-time tools and plastic concrete that can help a contractor immediately in evaluating the mixes, not only in the lab, but being able to evaluate the mixes on the job site. So one thing that happens with vibration, it is not static. When you pick up a vibrator, you can pick up several different types of vibrators. They have different rotors in them. You can run them at different speeds. But we have, in the last 10, 15 years, what we've done is we've made those vibrators controlled and predictable in the amount of energy that's put into the concrete. And then you can go in core samples and look at it and see where you're at with putting in a certain amount of energy. And the variability then, if you set vibrators to do the same thing all the time, put in the same energy, you will start seeing or trying to control, as we look at developing testing, where is the variability coming from? And in large part, what we find it comes from, we don't think it comes from the mix design. People would say, oh, that was the mix design. Why isn't it working here? And part of the problem is that you may have a batching issue. You may have smaller paving jobs that use dry batch. You may have your mix coming in the back of a transit mixer, or you may have it coming in a dump truck that came from a central batch plant. All of them add to the variability. So thank God we have some in the past 7 years, 10 years, box test and V. Kelly, pretty much. Yeah, been around for a while. It is more and more accepted. Every time I talk to a contractor, I bring it up and I say, look, if we want to match workability with vibration energy, okay, we have to understand that the more workable the mixture is, the better the gradation, the water cement ratio, the plasticizer, whatever makes this, the aggregate characteristic, whatever makes it more workable, you need to use less energy. And so what I'm going to talk about, because Peter actually did most of my presentation, thank you, so I can skip over a lot of slides. But we look at how we want to do it. And in the last, I chair the 309 committee, and you're going to see that 5,000 and 8,000 range is what the guidance specification is going to look like. You're going to, in that range. It's not picking out a certain speed, okay? And I kind of take vibration, and sometimes I try to talk waves. Sometimes I'm like, okay, how do I get people simple on the down low, how to understand vibration? And I kind of liken it to a piston, even though that, it's harmonically pounding the concrete, and the saw is helping it by separating out water, liquefying the concrete. All right, so you kind of need both of those things coming from one source, which is a vibrator head. It's going to have a set rotor in it, set amplitude or off-center weight, amplitude, and it's going to kick out a couple waves. And those waves are a pressure wave. That's what's helping that concrete get extruded through that paving machine. How do we get it to that flow? We get it to that flow by using the S waves, which are a very high frequency wave that is actually lubricating the inner particle. And also the S waves, they have a tendency to transfer through material differently by its density. So we will plow stuff. One thing we like to plow is water. That's what S waves excite because their density is very low compared to all the rock that's in the mix design. So the pressure waves, they go right through the material. They basically go right through the material. They don't do a lot of plowing. And when you get to the lower densities, it will move it. And with the S waves, and I don't want to get too much into that, but that is the process of paving. I want to extrude it with pressure, and I want to use just enough, just enough S waves or occurrence or frequency to be able to lower the amount of interparticle friction. So it's a balancing act. So when you look at the workability measurements, which is important, we look at what's the gradation, the characteristics, the sand amount, is it manufactured sand, what kind of water reducing agents are we using, the size of aggregate, the shape of it, the paste volume, which is very important because you need enough paste in between your rocks or else you're never going to vibrate the air out of it because there's not enough paste to fill that. And then water and the water cement ratio. How about process variance? And Peter, started talking about process variance through the whole picture. And obviously we're not using the slump cone in most DOTs. I think FAA doesn't use it either in looking at workability. Peter's talked a little bit about the electrical impedance curve, which we are in the looking at the development of kind of opening up the sensitivity in the grades of the curve. And you look at it and you overcome, mechanically, you overcome the stress, the static yield stress. And you can see from here, it's time. Okay, so we set a vibrator at 8,000. And every time that it changes in friction, you'll get a change in voltage over here. Okay, so when you set something, it's on a looping system. It says, I want to stay at 8,000. Please add or subtract voltage from it. As you're taking it and saying, okay, I got it to slump, but here is what we're really interested in paving, which is dynamic yield stress and that flow line over time. How is that changing? Can we look at its Stixentropic properties while we're looking at it? So we're in that development of curves coming from the vibrator, what's B. Kelly, whether Tyler's using it for box tests, and we're starting to add some amp draw so that curve has a better, gives you a better picture. Not as prone to bogus data, So we're working on that part of it. We have a pretty good idea of some of the signatures that electrical impedance is kicking out. So work in progress. But we look at the concrete variations. This is pretty standard. The rotor size, the size of the shell, the amount of amplitude, it's pretty standard in the paving industry. You're not going to see any variance on it. You're going to get the same vibration dynamics from it. And as we talked about, we look at this. This is probably the biggest thing that my company looks at because we can know what that is. We can quantify it, but I'm going to run through if you get out of kilter. Peter talked about that. But specification-wise, we have a certain spacing that we put in at 16-inch center. It's pretty standard in paving. We know that we get 4.6 G-forces in between here because our system picks it up. We know that's what we need to get air bubbles to come out because all we really want to do is take out macro air and leave it in the homogeneous state that it was delivered to us. So we got a lot of the factors that this isn't going to change. It's always going to be this way. We're dealing with two things, and that's frequency, because the rotors are always going to be the same. We're getting more into this range than the old range of we should run at 8 to 12. And 309 is going to reflect those changes in it. And they kind of think that 4 feet a minute's good. Most contractors are somewhere around 3 feet a minute, and that's 20 seconds in a cubic foot. That's a lot of time of vibration in a cubic foot. So we kind of slow down the frequency. Frequency, when it gets too high, when it gets in this range, has a tendency to separate. And this is the separation. You'll get thickness on the surface, as you can see. You'll get a hole right here where the aggregate should be. So you get poor arrangement from frequency. You get thickening from frequency. You get that from frequency, crummy edges. You get water pouring out of it. You can actually separate water in some mixes. And the timing will get wavy. They'll add to your IRI, which is how flat is your road going. And what we look at is the marriage between vibration energy that we're controlling. We're just looking at a couple of variables of it. And concrete workability has had a lot of research. A lot of people has helped out with nailing that stuff down. The research into workability versus vibration has a major progress the past 3 years. It really has. It really has. Both efforts combined open the door for machine learning. Okay, if my trucks are going to change, how can I teach my paving machine to look at changes in the concrete workability it's about to run over? How do we do that? Okay, and the only way to do that is let's control the vibration. Let's put science to it, and do the best we can with machine learning, using it as developing tools in plastic concrete on site that can give some tendencies of the workability so we can match that energy, vibration energy.